Lemon and pine-scented cleaning products contain volatile compounds such as monoterpenes, which can react in the air to form nanoparticles. These nanoparticles are classified as indoor pollutants and pose health risks to people who use these cleaners. Professor Philip Stevens from Indiana University tells Evelina Wang about these invisible indoor pollutants.
What we decided to do was to do a typical mopping of a room using a commercial cleaner that we bought at the grocery store. And then while we were mopping, we used several state-of-the-art instruments to monitor the chemical reactions that occurred and the particle pollution that was produced. And what we found was that inside there was enough oxidants, enough ozone to react with really high concentrations of the monoterpenes produced while you're mopping to produce pollution particles that were of similar concentrations that you might find standing next to a roadway in a city. And so that brought some health implications to these activities. So someone who's mopping for long periods of time could be really breathing in a lot of these particles.
So how can we, in general, avoid or decrease exposure and formation of these pollutants?
Right. So one way is to use cleaners that do not have these monoterpenes that give the lemon and pine scents. There are cleaners out there that may not have as high concentrations of these compounds in them. But also, if you reduce the level of oxidants in the home, then that could also reduce the rate of the chemical reactions that produce the particles. So adding filters that may contain things like activated carbon and other types of filters that are designed to remove ozone would definitely help reduce the rates of the chemical reactions.
I see. Circling back to the type of cleaners, are these monoterpenes you said and other types, are they listed in the active ingredients or?
Often they are,
Okay.
but you can also go online and find the manufacturer's more detailed list. But they're very common, not only in cleaners, but in a lot of other personal care products. Things like deodorants and air fresheners and things like that have these monoterpenes that are very reactive with ozone.
And those similarly would be able to react in an indoor environment and produce these
Right,
pollutants, as
right.
you say.
Depending on the concentrations, we just found that the mopping produced really high concentrations of the monoterpenes during the routine wiping of surfaces.
How quickly do they get into the air and react?
We found that, they rose very quickly. I mean, when you're mopping, you could smell the lemon scent and everything like that. And then we saw within seconds, we began to see the small particles formed, as well as intermediates in the chemical process, radicals and other oxygenated products that come from the chemical reaction. So we know it was chemical reactions that were producing the particles.
Could you comment quickly on the health effects of these particles and what happens to you when you inhale them?
Well, I'm just a simple chemist, so this is getting outside of my area of expertise, but you can look on EPA's website about the health impacts of particles, especially the small ones, which you tend to breathe in deeply and then they settle into your lungs. And the really small ones can get into your bloodstream and cause cardiovascular impacts. A lot of that impacts have been studied in terms of outdoor exposure to these particles. And it's not clear whether the particles produced by the cleaning, they're going to have a different chemical composition. And so it's not exactly clear whether they would have the same impacts as the outdoor particles from, say, automobiles. And that's an area that needs to be studied. What we hope from this paper is that more can be done to help protect people who are doing a lot of cleaning and just doing these routine activities in their homes.
For now, it may be best to stay away from lemon or pine-scented cleaners and install ozone filters indoors. That was Professor Philip Stevens speaking to Evelina Wang about a recent publication in Science Advances.